Very good morning and welcome to my course Basic Electronics Engineering. This course is generally made for BTech degree students of second year. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Badaipur, a college under JIS Group Educational Initiatives. Students, you can meet me personally at college premises, ground floor physics lab, or you can also send me a mail regarding your query or doubts in the given mail address, that is godphysics6@gmail.com or gopal.chakraborty_gkcem@jisgroup.org. I have a YouTube channel. Lots of video is already uploaded as per markout syllabus. You can go through that videos, and if you feel any doubt, feel free to contact me directly at college or via mail. Now, the corresponding course pages are www.markoutexam.net and www.markoutwb.ac.in. The syllabus is already uploaded in the university website. The link is given here. If you want, you can download the syllabus from the given link. Now, the title of the course is Basic Electronics Engineering, and the subject code is ESECE301. It has a category under Engineering Science course and has a credit 3 lecture per week. This course is generally made for BTech degree students of second year, third semester. But apart from all other departments, only the students of mechanical department has to study this course as a part of their curriculum of second year, third semester. So for this subject, I am your subject teacher. Now, in today's class, the topic that I am going to be discuss is basics of operational amplifier. In short, it is called OPAMP. Construction and characteristics of OPAMP. So these topics are also under module 1, that is semiconductor device and applications. Prerequisite for these topics is elementary idea of semiconductor physics. Course objectives is to provide an overview of basics of operational amplifier construction and characteristics of OPAMP. So after completion of this part of, students will able to understand the principle of operational amplifier, its basic construction, and different characteristics of an OPAMP. So these will be considered as possible course outcome. So, before going to start with today's topic, I would like to remind you that I have already discussed the basic of semiconductor physics, that is semiconductor, diode and transistor in my last videos. So the characteristic you need to know to understand the operational amplifier, because this operational amplifier is actually constructed with transistor. So you need to know what are the basic operations and characteristics of transistor. So here actually I am going to tell you what are the basics of OPAMP, what are the characteristics of it, and what will be the characteristic for ideal OPAMP as well as for practical OPAMP. So I like to remind you that please go through the last 2 or 3 classes videos lecture that I have uploaded, so that if you go through that class, it will be very easier for you to understand today's class topic. Now I will going to discuss the operational amplifier and its basic in details. So operational amplifier, it is also called OPAMP in short. It is an integrated circuit which can be used to perform various linear, non-linear and mathematical operations. An OPAMP is a decoupled high gain amplifier. You can operate OPAMP both with AC signal and DC signal. So in this chapter discusses the characteristic and types of different kind of operational amplifier. So the first thing is that construction of operational amplifier. So an OPAMP consists of differential amplifier, a level, translator and an output stage. A differential amplifier is present at the input stage of an OPAMP, and hence an OPAMP consists of 2 input terminals. One of those terminals is called as inverting terminal and the other one is called as the non-inverting terminal. The terminals are named based on the phase relationship between their respective inputs and outputs. So I will now show you what is the circuit symbol and basic construction of operational amplifier. So this is the basic symbol of an op-amp. Now this circuit symbol, here you can see this is one input, this is another input, and this is your output. Here within this two input, the negative one, that is called inverting input, and the positive one, it is called non-inverting input, or it may be called inverting terminal and non-inverting terminal. This is your output, and this is the connection of supply voltages. Here it is negative supply voltage, here it is positive supply voltage. This is an IC. Generally, OPAMP IC is known as IC 741. This is the number of OPAMP IC. Here you can see that 8 legs is there. Here 4, and in other side there is a 4 pin. Now within this 8 pin, this is the 8 pin IC configuration. Okay. So first pin is used for offset null. Second pin, that is inverting terminal or inverting input. Third pin, that is non-inverting input. Terminal number 4, that is a source voltage connection. Terminal number 5, that is again used for offset null. Terminal 6, that is output connection or output terminal. Terminal number 7, that is supply voltage, and terminal number 8, there is no connection. So this is the basic IC configuration of an op-amp or operational amplifier. So here the thing is that you need to know that you have to apply minus supply voltage and plus supply voltage here to activate the op-amp, as op-amp is mainly constructed with 2 transistors. So you have to first activate this transistor by putting the plus voltage and minus voltage here in 4 and 7 terminal of that IC. Then you have to check the offset null by the point number 1 and point number 5. So this is the basic circuit symbol and corresponding IC configuration of op-amp. Now the characteristic of operational amplifier. The important characteristic or parameters of an operational amplifier are as follows, that is open loop voltage gain, output offset voltage, common mode rejection ratio, and slew rate. So these are the four basic characteristics of an op-amp. First one, the open loop voltage gain, that is denoted by AV, equals to V output by difference between input, that means V1 minus V2. The open loop voltage gain of an op-amp is its differential gain without any feedback. So mathematically it will be written as the ratio of output voltage with the difference of input voltage. So that is open loop voltage gain of an op-amp. Second one, the output offset voltage. The voltage present at the output of an op-amp when its differential input voltage is 0 is called output offset voltage. Generally, what actually happens, you need to adjust the null, that is called null adjustment, which is very important. Now, why this thing will happen? Because as per the characteristics of op-amp, you will receive an output that is exactly 0 or no output when you put 0 voltage as the input or you just ground it. So without input there will be no output. But in practical, what you are able to see that when you put 0 voltage or you just ground the input terminals of an op-amp, you will get a very few amount of voltage at the output, but there is a presence of output voltage which is actually not wanted. So you have to nullify this output voltage, and the whole procedure is called null adjustment. So in IC configuration, the point number 1 and the 5th point, that's the offset null point. So within these 2 points, you have to connect a potentiometer pot, variable resistance, and by adjusting that resistance, you can nullify that output voltage when there is actually no input voltage. So this is your null adjustment. Now, why this thing will happen? This thing will happen because the op-amp is generally constructed with transistor. 2 transistors is there. Now, due to the mismatch of internal transistor, this output voltage generates. So it's not possible to make 2 transistors completely ideal. There may be some error, maybe a little bit, but there must be some error between this mismatch of 2 transistors. So by using a variable resistance or potentiometer pot, you can nullify that offset null voltage at the output. So this is the basic of output offset voltage. Next point, that is common mode rejection ratio. Common mode rejection ratio CMR of an op-amp is defined as the ratio of the closed loop voltage gain AD and the common mode voltage gain, that is AC. Mathematically, CMRR can be represented as CMRR equals to AD by AC. Note that the common mode gain AC of an op-amp is the ratio of common mode output voltage and the common mode input voltage. So this is the basic of common mode rejection ratio. Slew rate. Slew rate of an op-amp is defined as the maximum rate of change of output voltage due to a step input voltage. Mathematically, slew rate can be represented as SL equals to maximum of dV0 by dt through rate of change of output, where V0 is the output voltage in general. Slew rate is measured in either volt per microsecond or volt per millisecond. Now, what I have already told you, we are going to see two different type of operational amplifier. So one is ideal op-amp, another one is practical op-amp. Now this situation actually makes this different, because when you have to use op-amp in practical, there is lots of difference with the ideal one, because ideal one is theoretically proved or okay, and practical there is some difference with the ideal one. So this is the circuit diagram of an ideal op-amp. Now you see, from this op-amp we can conclude something, that is, first, input impedance, that is infinite, as there is no connection between inverting mode and non-inverting mode within the transistor, so it is input impedance is infinite. And output, what we have found here, it is completely short, so we can say the output impedance is 0. Open loop voltage gain AV, that should be infinite. Next point, that is, if the differential input voltage Vi, that is 0 volt, then the output voltage will be exactly 0 volt. Bandwidth is infinity. It means an ideal op-amp will amplify the signal at frequency without any attenuation. Common mode rejection ratio is infinity. Slew rate is also infinity. It means the ideal op-amp will produce and change in the output instantly in response to an input step voltage. Now this is a practical op-amp. You can see here the input terminal there is a huge amount of resistance. So the input impedance is the order of megaohm. Here the output is also short through a small resistance. So we can say that the output Z0 is in the order of few ohm. The open loop voltage gain that will be high. So a practical op-amp shows the following characteristics, that is input impedance in the order of megaohm, output admittance that is order of few ohm, and open loop voltage gain AV that will be high. So when you choose a practical op-amp, we should check whether it satisfies the following conditions. Input impedance Zi that should be as high as possible. The output impedance Z0 should be low as possible. Open loop voltage gain AV that should be as high as possible. So the last one, that is output offset voltage should be as low as possible. The operating bandwidth should be as high as possible. CMRR should be as high as possible, and the slew rate should be as high as possible. So these are considered to be the basic characteristic of an practical op-amp. These are the reference book that you may refer. The evaluation process is the same. Students have to appear for 30 marks internal exam and 70 marks in semester exam. Hope all of you have understand and enjoy today's class session. In next class, I will solve or derived other applications of op-amp. So, thank you.